Okay, this is just a real quick video to show you how you can get that equation for the tangent line without doing any calculations, just using your calculator. So this is really a good time saver for calculator-based questions, or to check answers when you're being asked to write the equation of a tangent line. And you are not allowed to use a calculator, you can use a check it. Okay, so first thing you do, I'm going to do this example right here. Okay, so we have a function, it's x squared minus 3 all to the 4th power. We know the tangent line when x is equal to 2. So if you just recall from the calculations, right, we substitute 2 into here, get the y value, which is 1. So our point of tangency is 2 comma 1. We take the derivative of this, which involves the chain rule. We plug in 2 to evaluate it. We get a derivative of 16, which is our slope. And then this is our equation for our tangent line at 2 comma 1. Remember, this is a circuit packet back from unit 3. So remember, this is just an answer, a random answer to some other question. Okay, so this is how you do this all on your calculator so that you don't have to do any calculations really. But 2 things before I get started. 1, again, this method is excellent for calculator-based questions. 2, though, the majority of the tangent line questions are on your calculator parts of the tests. So you're definitely going to have to be able to do it by hand, but this is a good check-in. Okay, so the first thing we do is, let's get rid of everything here. You're going to want to put the function in your graphic. And so I'm going to put y1 here, and it's the quantity. I'm just reading right here. X squared minus 3 all to the 4th power. Okay, and I'm going to go ahead and graph that. And I probably need to, let's do a zoom standard here. Just get back to our standard window. Zoom 6. Okay. So here's that 4th degree polynomial. It's actually an 8th degree polynomial, I guess, if you pull it up. Okay. So 2 comma 1 over here. I'm going to mess around with my window here just for kicks and giggles here. Let's just say my x min is, hold on, let me look at that graph again. 2, 3. My x min is negative 3. My x max is, let's put up 4. Let's do a y min of negative 1. Let's do a y max of, let's go 6. Okay, let's graph it now, just to get a little better idea. Okay, there we go. So this is 2 comma 1, tendencies right here. Slope of 16, right? That's the same. Slope of 16 is super steep, right? Okay, so this is how you get your tangent line. You have to go to the draw feature. The draw feature is right here. It's your program key. Okay, so draw, you access that by second program. So second program, and notice, let me go back to here. I'm doing second program while I've got the graph on the screen. That's the mode you have to be in. Okay, so I got the graph on the screen, I go second, draw, and then here's your tangent, option 5. Okay, and now I want to tell it the point of tangency. So my point of tangency here when x is equal to 2. So I'm just going to type in 2 sets of x equal to 2. And I'm going to hit enter. And then it's going to draw that, there it is, that tangent line right here. And here is the equation. So notice it's 16x, right? We talked about all of these decimals here that our calculators determine slope numerically. Okay. And so with limits. And so all of this is round root error. So when we see this, we read this as 16x minus 31. Again, round root errors. The numeric process that the calculator uses. So let's take a look at here's the equation of tangent line. If we distribute the 16 I get 16x minus 32 plus 1. So that is 16x minus 31. So that is how you get your tangent line all on your calculator without having to go through all of these steps. It's a great way to check your work. Again, I'll say it again, the tangent line equations, by and large, they're asking you the equations of tangent lines on their calculator. So you definitely have to know these steps and know how to do them, but this is a great way to check your work. So that's just a quick tutorial there. One last thing before we go, and that is this. I'm just going to see if this happens. Because this tangent line was drawn, right? We used the draw function. It's not geometry, and it's not algebra. It's not a function that's in there we can manipulate. It's literally drawn in. Okay. If you notice this draw feature, you can draw a whole bunch of things. You can shade, you can, there's more things. You can draw a circle, which isn't a function at all. You know, there's a lot of things you can do in that draw feature. So the idea then is we have to get rid of that. So for instance, watch this. I think this is going to work the way I'm thinking. I'm going to get rid of this function and go back to the graph. Yeah. Well, I guess it's not there. Huh. Sometimes that doesn't happen. Sometimes when you get rid of the functions and stuff, the tangent line still is there. So let me just show you how to get rid of it if deleting the function doesn't work. I have a CE, it's a mirror, this is an emulator, but the mirror CEs might automatically delete that drawing when the function that's connected to it is deleted. But I bet the older calculators don't, like the ones with the liquid crystal screens. So I'm going to put the function back in. Now, the tangent line is not going to come back in because I have to draw it again. I'm going to draw the tangent line again at 2. There it is. Okay, so like I said, this is drawn in there. You can actually erase it. And the way we do that is we go second, draw, and clear drawings. So this option 1 will take the second eraser. It'll go back and get rid of it. So the second drawing 1, then that tangent line is no longer there. So if you have a random tangent line or some random shading, we'll use some shading in the second semester. That's how you get rid of those things, just so you know.